Hello, my students in grade 9. This is Mathematics Lecture 4, and the title of our lesson is Lines and Circles. As you can see, this week we will start with part 1 of our lesson, and next week we will continue. And the geometry in these two parts is a revision of the things we have seen in grade 7 and in grade 8 before. What are we going to refresh our memory about in this lesson? First, we will revise triangles, the isosceles triangle, equilateral triangle, right and semi-equilateral. Then we will talk about remarkable lines in a triangle. Which lines can we draw in a triangle? Last year in grade 8, we studied quadrilaterals, parallelogram and its properties, special parallelograms, the square, the rectangle, and others like the rhombus and the trapezoid with their properties. First, I will start talking about the triangles. Kinds of triangles. We have special kinds of triangles. The first special kind of triangle is called the isosceles triangle. Why do we call it an isosceles triangle? What are the properties of an isosceles triangle? Number one, it has two equal sides issued from the special vertex in it. Number two, it has two equal angles. These are called the base angles or the angles at the base. Number three, the height issued from the special vertex is at the same time called a median, a bisector, and perpendicular bisector. Let me give an example about each one using triangle ABC. As you can see, triangle ABC is isosceles. How did I know? Because there is a mark on side AB and the same mark is on side AC. So since side AB is equal to side AC, as I can see, then this triangle is called isosceles of vertex A. Why is the special vertex A? We said before, always in an isosceles triangle, the equal sides are issued from the special vertex. Now, who are the two equal angles here? So if A or on vertex A or angle BAC, A is the special vertex, then always the side opposite to the special vertex, which is BC, it is called the base. And on BC, we can see two angles, an angle ABC and an angle ACB. These two base angles are equal. Always, if I draw from the special vertex a height to side BC, this height is at the same time a median, a bisector, and a perpendicular bisector. How can we prove that a triangle is isosceles? If we can prove that a triangle has two equal sides or two equal angles, which are the mostly used, then this triangle is an isosceles triangle. Equilateral triangle, what are the properties? It has three equal sides, so the three sides have the same measure, and it has three equal angles. Each angle is equal to 60 degrees. So if this triangle is ABC and it is equilateral, then side AB is equal to side AC is equal to side BC. Angle BAC equal angle ABC equal angle ACB, and each angle measures 60 degrees. Now, if I draw a height from any vertex, from vertex A or from vertex B or from vertex C, this height will be at the same time a median, a bisector, and a perpendicular bisector. If I wanted to prove that a triangle is equilateral, we can prove that it has any triangle having three equal sides or three equal angles, or we can prove it is an isosceles triangle with one angle equal 60 degrees, then it will be equilateral. When I talk about the right triangle, what are the properties? it has one right angle. So this triangle, as you can see, one of its angles is right. Always the side opposite to the right angle is called a hypotenuse. The other two sides, this is called leg 1 and this is called leg 2. Always leg 1 and leg 2 are perpendicular. How can we prove that a triangle is right? If we can prove any triangle having a right angle equal to 90 degrees, it will be a right triangle. Now, please, this triangle is very important and we should study its rules and memorize them. These rules, we use them a lot in grade 9. The semi-equilateral triangle. What is a semi-equilateral triangle? It is a triangle having three angles. The first angle always measures 30 degrees, the second angle 60 degrees, the third angle 90 degrees. It is also called the 30 degrees, 60 degrees, 90 degrees triangle. What are the properties of a semi-equilateral triangle? It has three angles. The first one, as I said, 30 degrees, the second one 60 degrees, the third one 90 degrees, and you can see this in the figure. Always, since angle ABC is equal to 90 degrees, then AC is the hypotenuse. Now, look at the 30 degrees angle at vertex A. Which side is opposite to A? It is side BC. So we always say the side opposite to 30 degrees. If I wanted to calculate its measure, I use this rule. Side BC equal hypotenuse over 2. The sum of the hypotenuse over 2. So if the hypotenuse measures 8 centimeter, then BC will measure 8 over 2, 4 centimeter. Now, the side opposite to 60 degrees. This is the 60 degrees. The side opposite to it is AB. So if I wanted to find the measure of AB, we use the rule which is the side opposite to 60 degrees, which is AB equal hypotenuse radical 3 over 2. And as I said, if the hypotenuse is 8, then 8 radical 3 over 2 gives me 4 radical 3. These rules should be memorized as you know your names, because these two rules, we always use them in our proof in geometry. Now, what are the remarkable lines in a triangle or special lines in a triangle? We should know the definition of each line and how do we draw this line. The median segment in a triangle, it is a line from the vertex. We draw it to the opposite side, to the midpoint of the opposite side. So if I wanted to draw the median issued from A, it will be issued to the opposite side BC. So first I find the midpoint of BC, which is the point in the middle. I divide the measure of BC by 2. Then N is the midpoint of BC. I bring the long ruler. I simply join A with N. Also, in the same way, I draw the median BM to AC. In the same way, I draw the median CP to AB. After I draw the three medians in a triangle have the same meeting point, or they intersect at the same point. This point of intersection of the three medians is called a centroid or a center of gravity. Also, there are properties of the centroid. If I wanted to calculate AG or CG or BG, if I wanted to calculate AG, it is equal 2 over 3 AG, 2 over 3 AN, and GM equals 1 over 3 BG. Now, that number 2, the height or altitude or perpendicular in a triangle. It is a line from the vertex perpendicular to the opposite side. So I simply draw a perpendicular from the vertex to the opposite side, I get a height. After drawing the three heights in a triangle, they're using the set square. Their point of intersection is called the orthocenter. So we should know the point of intersection of each three lines. We should memorize this. The bisector in a triangle, it is a line that divides an angle into two equal angles. So for example, if this angle is 120 degrees, I divide the measure by 2, and using a protractor, I draw the bisector of the angle. After drawing the 3 bisectors for the 3 angles, the point of intersection is called the incenter. Number 4, perpendicular bisector in a triangle. It is a line perpendicular to the segment at its midpoint. So also for each line, I draw a perpendicular bisector. First, I mark the midpoint of the segment. I bring the set square and draw a perpendicular at the midpoint. The meeting point or the intersection point of the perpendicular bisectors in a triangle is called the circumcenter. Why do we call it the circumcenter? It is the center of the circle circumscribed about the triangle ABC. So after marking this point, which is the circumcenter, if I bring the compass, I put the needle here and I open my compass till this vertex and I draw a circle. This circle will pass, as you can see down here, through the 3 vertices. Note a very important note. Always in a right triangle, the center of the circle circumscribed about this triangle is the midpoint of the hypotenuse. So the radius of this circle will be the hypotenuse over 2. When we talk about collinear points, 3 points or more are said to be collinear if they belong or lie on the same line. As you can see, A, B, and C are 3 points on the same line. Then I say point A, point B, and point C are collinear. How can we prove that these 3 points are collinear? If we can prove that angle ABC is equal to 180 degrees, then they are collinear. If I can prove that AB plus BC is equal to the measure of AC, then they are collinear. Finally, if I can prove that AB and AC are parallel to the same line, then they will be collinear. Last year, we studied the quadrilaterals. Any quadrilateral is a geometrical shape having 4 sides and 4 angles. The first quadrilateral I'll talk about is the parallelogram. What are the properties or the definition of the parallelogram? It is a quadrilateral whose opposite sides are parallel. The quadrilateral parallelogram has properties. So in a parallelogram, each pair of angles are parallel and equal, or then the quadrilateral is a parallelogram. If we can prove that any 2 pairs are parallel and equal, then it is a parallelogram, or the diagonals bisect each other, they intersect at their midpoint, it is a parallelogram. Any 2 opposite sides are equal and parallel, and consecutive angles are supplementary. What do we mean by this? If I add the measure of 2 angles coming after each other's and they give me the sum of 180 degrees, then it is a parallelogram. We should study the area of the parallelogram. It is base times height. This is the parallelogram. Now the square, by definition, a square is a quadrilateral having 4 equal sides and 4 equal angles. So this is the square. What are the properties of a square? In a square, all the sides are equal. The 4 angles are right. Each angle measures 90 degrees, and the adjacent sides are perpendicular. AB is perpendicular to BC, BC is perpendicular to CD, and so on. The diagonals bisect each other and they are equal to each other. At the same time, they are perpendicular. The area of the square is equal to side square or S square. Now we'll talk about the rectangle. A rectangle is a quadrilateral which has 2 equal sides. Each 2 opposite sides are parallel and equal. This is a rectangle. So AB parallel to DC and equal, AD parallel to BC and equal. Each 2 opposite sides, long opposite sides, are called length. Each 2 small sides are called width. In a rectangle, the four angles are right. Each two opposite sides are parallel and equal. Each two adjacent sides are perpendicular. The diagonals are equal and they bisect each other's. The area of the rectangle is equal to the length times width. Now we'll talk about the rhombus. The definition of the rhombus, it is a rectangle, but it has equal sides. Same, but it doesn't have right angles. What are the properties of a rhombus? All the sides are equal. Any two opposite angles are equal. Any two consecutive angles are supplementary. Their sum is 180 degrees. Any two opposite sides are parallel. The diagonals are perpendicular and they bisect each other's. The diagonals bisect the angles. The area of the rhombus is diagonal 1, this is the diagonal, times diagonal 2, all divided by 2. The last quadrilateral is the trapezoid. This is the trapezoid. A trapezoid is a quadrilateral with two parallel sides only. AB is parallel to DC. AD and BC are called non-parallel sides. So if two non-parallel sides are equal, then the trapezoid is called an isosceles trapezoid. If two of the angles of the trapezoid are right, it's called a right trapezoid. The area of the trapezoid is small base. This is the small base plus the big base times height, all divided by 2. The median of a trapezoid, suppose I have a trapezoid ABCD. Why is MN a median? I look at the non-parallel sides. I take M, the midpoint of the first non-parallel side. N will be the midpoint of the second non-parallel side. So if I join MN, it will be parallel to AB and DC. Now, the diagonals AC and BD cut MN in P and Q. So if I wanted to calculate the median MN, it's equal to AB plus DC over 2. If I wanted to calculate PQ, it's equal to DC minus AB over 2. So this was our quick revision about triangles and quadrilaterals. There are many definitions to be memorized and studied. As you can see, we should study all these definitions to be able to solve in our coming exercises. If you have any question, just ask me.